Hello, and welcome to this unusual session. This session is not going to use a lot of slides. It's going to use a couple of pictures, but most of the session is about code. So if you love code, you will see a lot of code. It's not going to be any code. I'm going to develop a set of reactive microservices. I'm going to package them inside containers and deploy them on top of Kubernetes. And to run and to develop those microservices, I'm going to use Eclipse Vert.x. So I just mentioned reactive a few times. Reactive is not new. And if you look at the Oxford Dictionary and look for reactive, reactive means showing a response to a stimulus. So if we apply this definition to software, reactive software is a software showing responses to stimuli. Well, so that means that almost every piece of software we built since the 60s is somehow reactive because it's there to react to your user input or just input in general. So that's absolutely true. What changed recently is how we are building such kind of systems and why we are building them a little bit differently. In the Java world, reactive can be divided in 3 different clusters. The first part is reactive system here, which is an architectural style that we can summarize as distributed system done right. By infusing asynchrony at the core of your system, you are able to achieve elasticity and resilience very easily. Why? Because every time that your components are interacting, they are always using messages. So they don't point to a specific consumer, but they are already using messages. Obviously, building reactive systems is not simple. If it will be, we will all build that, and we are not. So to help you with this, there is reactive programming, which is an API that lets you compose and develop event-driven and asynchronous software. The idea behind reactive programming is to use streams and data streams as the main construct in your code. So you have data streams and you are observing them and assume that you have a data inside your data stream, you are notified and you can process it and so on. So it looks very nice, but the shift to learn it is kind of complicated. Why? Because to build reactive programming, you need to understand the observer pattern, the iterator pattern, and functional programming. And all these are going to be mixed with object-oriented programming inside your Java code. So there is a shift here, but it's very interesting to understand it, and you are going to see more and more of those technologies with Spring Reactive, Airy Java, or even Kotlin Go are going this way too. When you do data streams, there is one issue you need to tackle very, very quickly. What happens if you have a data stream that is consumed by someone way slower than the producer? It's pretty simple. Your system is going to collapse because in all you run out of memory. So and that is provide. And generally touch it.
My name is Ritesh,
and it's not.
We are
Core interfaces
associated.
all about implementing them right is complicated. I also mentioned microservices. Who say it's going to be simple to switch from monoliths to a set of distributed software that are going to interact using a loose-coupled, lightweight protocol? Well, it's not. It's not because anything can go wrong at any time, and you are not under control of everything.
Bare necessities.
A piece of software you are integrated inside your system can evolve, can be updated, can be broken at any time, and you need to be prepared for that. So microservices means, if you are developing microservices, it means that you are prepared to fail. You are prepared to write your code in a way that, yes, I know, this may fail for whatever reason. Out of memory, timeout, firewall, updates, failures, bug. So you need to understand that. But end of talking, it's time to see some code. So I'm going to create my first microservices. And for this, I'm going to create a module in this project. It's going to be a Maven module, yes. I'm going to call it shopping backend. Because I forgot to say that I'm also going to solve the first world problem managing my shopping list. You will see why. Yeah, an iPhone here. Okay, so yes, added to. So this is a very simple Maven project. There is nothing fancy inside. I'm going to make it a little bit more interesting. Backend. No, just need to copy command here. Yep. I'm going to make it Vertx. There we go. So we have the Vertx Maven plugin, which has a setup command that is going to modify this one and just say.
Yes.
So, that's an old one. Let's use the latest Vertx. So this is going to declare a vertical, which is going to be the entry point of my application. We are going to see that. It has added the Vertx BOM file and a few dependencies. And actually, a Vertx application just needs this one here, Vertx core. That's all. I've added a few other things, Redis, web, and so on, because the microservice we are going to build needs this one. And so on. And we have the Vertx Maven plugin that is just there to package our application. It's actually not required, but it's nice. You will see why. And also, I've generated vertical, which is a very simple Java interface like this with abstract vertical, and not with two spaces. Yeah. And the first thing I will do is create an HTTP server. So remember, reactive. Reactive is about reacting to stimuli. My stimuli here is going to be my HTTP request. And I'm going to do something like, well, when I have a request, just say, hello, Singapore. Something like that. And I need to say on which port I'm going to start it. Oh yeah, you need to be Java 8. So Vertx requires Java 8. Why? Because we are using a lot Lambda and method references. So if you are under Java 8, don't even think about using Vertx. If you are using Java 8, 9, 10, and the incoming 11, you can use Vertx. So here is my code of my first application. I go back here. I do Vertx run. And it's going to run it. And yep, there it is. And now if I go there, we should see, hello, Singapore. So a few things that are interesting with a Fabricate, with a Vertx Maven plugin is that I can just do this, and it's going to recompile my application using the Maven build process, not an add-on or ad hoc compiler. So it's really going to replay it. And it's very fast because Vertx is actually very fast. So, okay, but we want to build a microservice, and most of our microservices are about HTTP endpoints. And as I said, we want to manage my shopping list. So my shopping list is going to be a map, string, integer, so product and the quantity, that I will call list because then it's confusing. Naming is always hard. Here it is. And now I need a REST API. If I do the REST API here, it's going to be very complicated. If it's the verb is get, the verb is post, and so on. So fortunately, Vertx comes with an interesting component called Vertx Web, which provides you a router, in which I can declare route. So for example, let's keep our route here. Response and hello. So this is going to be our route, the root of our system, but then I will have my API like /shopping handler. And when I have a get on shopping, I'm going to call this get list method that I need to develop at some point. When I do a post, I will do add to list. And when I do a delete, I delete a specific product that I can pass in the path like this, delete from list. All right, I will implement them, but first thing, there's two things to do first, is to replace this by the router. The router is an accept method that is doing exactly what we imagined to do, so it's just going to look at the request, find the right route, call the route. And I also need to add the body handler. By default, for performance reason, Vertx is not passing the body because it's actually expensive. So you need to add this line. Okay, time to implement those methods. The first one is getList. Well, Vertx is a lot about JSON. So we are going to return a JSON object. So for this, I get my response. I want to write something, and it's going to be my list encoded as JSON. Oh, let's say prettily. You just add indentation. Okay, done. First method implemented. What about the second one, add to list? So in the add to list method, I will get from my body the name of my product, get string name. As I said, we also have our own JSON API, so you can manipulate JSON object like this, and we will have the quantity, get integer, quantity, and this one is optional, so let's say that if we don't pass 1, then it's going to be 1. I add that to my list, name, quantity, and then I just call getList, and I'm done. Next one, delete from list. So here we have the name pass parameters that I will retrieve like that, name, and I will just remove from the list and just call getList. I have implemented my REST API in 3 minutes. So let's have a look. Does that work? So here we should have hello. Yes. And should we have a shopping list? Well, I have nothing in my shopping list, so let's try to add things in my shopping list now. Shopping name equals, I need bacon. Yeah, and here we have bacon. Let's say that I need coffee, too. And I need a lot of coffee. 12, at least. And we have 12 coffee. Cool. Can I remove the bacon? We should be able to delete /bacon. I need to remove this. And now we just have the coffee. It's good for my diet. So our REST API works, but as I said, we want to deploy that on the cloud, and we need to do that by doing a container first. But before this, let me introduce you to Openshift. So Openshift is a distribution of Kubernetes that we do at Red Hat. So it runs on any operating system as soon as you have a container host. We recommend Rail, of course. And then it runs Kubernetes. So Kubernetes is going to take your containers and orchestrate them. So that means deploying them, being sure that they are still alive, managing all the networking between them, doing the storage, so the volumes, persistent volume and so on, managing the logging, metrics, security, and so on. So all the boring stuff. On top of that, Openshift is adding a few features like the build and deployment automations. We are going to see that immediately. It also adds a set of existing services that you can just instantiate. You have seen in the previous, during the keynote, SSO or and other services that was just there and instantiated like that. But before showing you this, we need to have a discussion about containers. Containers are not about isolation. Definitely not. They are doing a pretty bad job at isolating things. Containers is about sharing. It's about increasing your deployment capacity of a single node by doing more stuff on a single node. So that means that when you run 5 or 6 containers side by side on your machine, they're all sharing the same CPU. That makes sense, right? When you do that on the cloud, it's exactly the same thing. If you deploy all your containers on the same node, they're all sharing the same CPU. Okay, so now what about an application that is using a lot of memories or a lot of CPUs? Well, if it does that, then the other containers get less. And it's not cool. It's not fair. So then you implement quotas. Great. What happens when one of your containers reaches a quota? It's killed. That's great, right? So you need to be aware that when you do containers, you need to understand what the CPU and memory that your application need, and you need to use a development model and runtime that take care of this for you. Vertx is going to take care of this for you because it uses a very, very few number of threads, which cause a lot of memory, and handles a load with a single thread because of the reactive engines it has. So let's have a look to this. So we say that we need the containers. The easiest way to build the containers is to create a Dockerfile. Okay. Here it is. My Dockerfile, 5 lines. I want Java. I will expose 8080. I copy my file jar to some directory inside my containers, and I just start it. Done. Let's do this. Where I am? No. Wrong time. I will stop that one. With Docker. So I'm going to package my application using the Vertx Maven plugin that builds a file jar. Great. Then it's going to create a build on the Openshift side. We're going to see this. Uploading my content, so my file jar, to Openshift, and Openshift is going to build my Docker file. My Docker container is not built by my laptop here. It's built by Openshift. That means that it has all the traceability and knows exactly when and why a container has been created. So if I go there and see builds, I see my shopping backend here. I can see the log. From Java, expose, and so on and so on and so on. So exactly the one we have executed. And it runs it on Openshift. It goes directly inside the Openshift Docker registry, which actually is a Kubernetes Docker registry. And when this is done, it's going to instantiate it. And here it is. We have our shopping backend here. Hello. And what do I have in my shopping list? I have nothing. So let's add a few things inside my shopping list. /populate. Okay, coffee, eggs, and bacon. That's my breakfast. Yeah, I need a lot of protein. So that's great. But if you're using the cloud, most of the time, it's because you have scalability issue. So what you will do in Openshift, you come here and say, hey, can I click on this button here and get 2 instances of my applications? And you will do it. So let's do it. So we are going to run a second pod, and now we should have them. Okay. And if I go there, oh, everything fine, sounds fine, okay. Let's have a look. If I do, I will need this URL. Here. Oh, my shopping list empty. Oh, and this one has the data. Empty, data, empty, data. This is exactly what I was talking about, the first world problem. Split shopping list. My shopping list is different from the one for my wife. It's terrible. Every time that I go to do the errands, I'm missing something or adding something else. So we can't do that, so we need a system, and we will build it using microservices. It makes a lot of sense here, because the issue is that the list is stored in memory. So if I have 2 pods, they're not sharing the same memory. So we need to fix that. I've deployed Redis for this. You could use any database, but Redis is kind of cool in terms of API, and we will remove this list here by doing Redis client. And I need to find it. And here we are on the cloud. So I cannot create a new Redis client because I don't know the IP, I don't know the port, I don't know the authentication port, and so on, but I have service discovery. So I can ask Vertx to say, create a service discovery object. This is going to be asynchronous, that's why we have a lambda. So when it's done, we got this. And now you need a Redis data source. Get Redis client, pass the discovery. And let's pass, I know the name of my service is going to be called Redis. So I'm just asking Vertx to say, okay, look for a Redis data source that has the name Redis. From this name comes from here, Redis, this name here. So it's a public, well, the internal public name of my Redis database. So once I have my Redis, well, 2 things can happen. It can fail, because maybe Redis is not there, and then we will use a meaningful error message, like this one. Or we can have Redis, and then we just do Redis dot result. So we found the Redis, here it is, and then I'm going to start my HTTP servers once I have my Redis server. Okay, cool.
Fine.
So now we need to modify the other one. So this does not exist. I'm going to use the Redis client and HDL and shopping name x and so on. So I just ask Redis to delete the entry name from the shopping key and to return the resulting list. I will do the same thing here. Set shopping name quantity to string. Our API requires string here.
Line.
We should improve this at some point actually. This is the Vertx Redis client that. This one is a little bit more complicated. So I will do redis.hgetAll shopping. Okay. And then I will get maybe a JSON object. Because maybe it's failed, and in that case I would just say failed. Or we have it, and then I will just return this, almost this. So we don't need the list anymore because we already got the object, and done. Let's repackage this. There we go. We are going to build the package again, redeploy it. So we will see it here, and something interesting is going to happen. So we have to check that. So in a few minutes, we switch from an in-memory backend to a Redis database. And here is going to deploy it because we have built a new Docker image and Openshift, because this is not done by Kubernetes, but the deployment automation from Openshift is saying, oh, there is a new thing. And it has implemented a rolling update. So a rolling update is just starting the new pod and then stopping the last pod when Openshift believes your application is ready. He tried to make an educated guess, and believe me, he's not really good at it. We will have to give some ideas about when it's done. But first, let's check this. So my shopping needs to be empty now, because now we switch to Redis. But if I populate here, now we should start seeing things. And if I, if we do this, I now have a single shopping list shared by my two pods. Every time it's the same thing. So as I said, when it does a rolling updates, we need to help him a little bit, or you will have downtime. So to do that, we need health checks. Or you don't need to do a lot of things to add health checks. You can just go to configuration here, and it say, oh, you don't have health checks. You don't add. There is two health checks. Readiness, which is used when we do rolling updates, because it waits for readiness, or liveness, which let you know when things have crashed. I'm going the hello response for this, and save it. It's going to redeploy it. Okay, so it's starting, and now we have this light blue. That means that it has started, but it's not yet ready. And when it's ready, it kills one, and so on. So with this process, we don't have downtime anymore, because we know when the application has started. So here, the liveness and readiness checks are very simple. It's just hello, but you can imagine very, very complex one. We have an API for that in Vertx. One other thing you can do is to check if it works, is to go to the terminal of one of your pods. I do a PS, and here we have the PID, and what a developer do with a PID. Right? We all do that. Let's kill it. So it's killed. So what happened here? Here it say, hey, something bad happened. The liveness check starts saying that it's not good anymore, and it will restart it immediately. So with Openshift, something very bad happens for us, developer. We can't kill the system anymore. It's going to restart. That's very annoying. We are losing our control of being able to break everything. But it seems to be good for production. Okay, why not? So one microservice is not a microservice. We need at least to have a second one. And we are going to have a second one right now with this shopping service that is going to depend on our first shopping list and on a pricer service that will give me an idea of how much it's going to cost me. when I go to the shopping mall. So let's close all of them.
Maybe apply.
Close all. So this one, I'm not going to use a Dockerfile. I'm going to use the Fabricate Maven plugin that does exactly the same thing, but from Maven, so I don't have to do anything. So it's this Fabricate Maven plugin. You just say resource that compute all the Kubernetes metadata and build, and you're done. And I'm also doing the health checks automatically, so I don't have to configure anything. The Fabricate Maven plugin knows the Vertx Maven plugin, so they work together. So here it is. So in the first microservice, we have developed callbacks. Yeah, we don't like callbacks, right? Because as soon as you have callbacks, the code is not readable anymore. Here we are going to use reactive programming and see how using streams are going to simplify the development of such kind of applications. So I still have a router, fine. That's my health checks and so on, and it's going to call get shopping list. But the first thing is that we need two services, the pricer service and the shopping backend. So I will say HTTP endpoint, and here I need the right one, and this one. Rx get web client. So first, look at Rx, the Rx prefix. It tells you that it's going to use a reactive programming API, which here is Rx. So I pass discovery. I will pass the name of the service I want, pricer service, okay. And this is going to return a very weird stream, which is called a single. It's a data stream, but it can only emit one data. So it means that when the service has been discovered, the stream will get the discovered service. Let's do that for my second service, which is the shopping backend. So the service we just developed right now. Shopping backend. Without a space, it's better. Let's call it SQ because names matter, right? And then I want to be sure that both services have been retrieved. So I need to join them. Because we're using reactive programming, we can zip streams. So meaning that we will take one data of each. Good news, we have only one data in each. So let's do S1, S2, and then we will have the two data emitted by the stream, and the pricer field will be assigned to P, and the shopping field is going to be assigned to S. And then I will just start this one when both are done. Well, you may wonder about something here. What about concurrency? You don't care. You don't care about concurrency if you're using Vertx, because Vertx uses a single thread. If you're using a single thread, concurrent access, there is not that much, right? Because there is a single thread. So you don't need synchronize, you don't need volatile, you don't need anything. So this is a single, and one thing very important when you use reactive programming is this line here, subscribe. Data streams are lazy. Pretty sure they are French, but doesn't look like that, yeah. So if you don't tell them that you really, really want the result, they won't do anything. So you need to subscribe to tell them, yeah, I want you to do something. And here it is, I have this. So now we are going to implement this part here. So that's the handler that is called when we call the server. So I already retrieved the response from our shopping backend. So by calling /shopping, this is a JSON object, okay? And now for each items that I have in my shopping list, I'm going to call the pricer. So remember, I have eggs, bacon, and coffee, and so I will call the pricer 3 times. So I will do single dot flat map publisher. So this is my JSON object, and I will return Flyball dot from iterable JSON. So a Flyball is a data stream that contains here 3 data, my 3 entries of my JSON object. Flyball means that back pressure is going to be supported. It means that it implements reactive stream and so on, but you don't care, you just use Flyball and you're done. So once you have this, you now have a stream of 3 data. For each item, I'm going to say, call the pricer service. So because I don't have lots of time in this session, I will just retrieve the price using this utility method. All the code is going to be open source, so don't worry, you can look at it. It's very simple. It's basically the same thing as here. And now I have the results, and I will just do a subscribe. And every time that I got a result here, so I will call that JSON. Everything can be called JSON. I need to write the result of the pricer into my HTTP response. Wait. It's a stream. I will have one result at a time. I don't have everything. How does that work? Good news. HTTP support chunked responses since a long time, and you should use them more. Don't wait to have the complete HTTP responses inside your memory and flush it. This is pretty bad in terms of memory. So let's do that and write it inside my server response, and here it's my JSON object. If it failed, well, if it failed, then we just failed. So it will generate a 500. And when we are done, so when we have called our pricer 3 times, let's close or end it, the server response. Yeah, make it beautiful. So this server response has been configured to be chunked. So now I have this. Let's see how it works. Oop. Shopping list. So I'm using the Fabricate Maven plugin to deploy it. It's going to do exactly the same thing, build the fat jar, send it to Openshift, make the magic happen over there, and here it is. So it's a little bit slower because it's using a different way to build it. It's using what we call source to image with binary content. It's more production ready, let's say. So before, our Docker image had 5 layers. This one has 26 layers because I added monitoring, logging, and well, all the stuff that we don't really care, except production care about it. So it's better to use this way. And now it should be there. Here it is. Yep. And if I go there, does that work? Here it is. Up. So for each entries, we have called the pricer, and the pricer returns a random number because lines. That's done. So let's redeploy it with this and see how it works. So the idea behind a circuit breaker is monitoring the number of failures when you have one interaction. And if this number of failures reach a threshold, then stop calling it and inject a fallback instead. Your users can understand that your system may not be 100% available right now, but they hate waiting. So remember, failing is fine, waiting is not. And the circuit breaker lets you do that. And the circuit breaker also has an auto-recovery mechanism. So after a reset period, it will check, will let one interaction pass to check if the service is back on track. And if the service is back on track, then you will call it again and again. So circuit breaker is not about resilience only. It's about respecting the other services. When a service is not in good shape, okay, give it some space. Then when it goes back on track, when it's back on its leg, kick it again until it crashes again. So it's very important to use this. So let's see if it works. Oh, so what happened is that it failed. So the first one triggered the closed state, so I'm not calling the open state, I'm not calling the service anymore, and the two other responses have been immediate. So the first one timeout, and the second one are immediate. And this is a fallback. It's a tribute to JavaScript, not a number. So now, if the service becomes back on track, here, we are going to let one of our interaction pass. And what is interesting here is that the two first one still fail because we still use a fallback. And the last one, okay, the last one succeeded. So if I retry, we should have our price again. So circuit breaker is very, very interesting when you are relying on services that may be slow, may be under updates, and you really want to limit that. Last thing, because I think it's this. It's all I have in terms of code, but I just want to discuss a little bit about why using reactive when you are doing cloud or microservices. Be aware that you are running on the cloud, probably inside containers, and containers are about sharing. And if you are sharing the resources with your other sibling services and microservices or functions, you need to be aware of the amount of CPU and memory you're using, or pick a runtime that will do that for you and use the resources efficiently. That's what Vertx do. By using a very smart event loop system, it will just use the right level of resources to handle almost everything. One Vertx application on a Raspberry Pi B, so not the latest one, Raspberry Pi, is able to handle 10,000 requests at the same time. Try with any other runtime. And it's Java-based, so you can't say, yeah, but no, it's the JVM, it's part of it. If you want to contact me, you can send me an email to this one or contact me on Twitter here. If you're interested by Vertx, you can follow us on Twitter. Here is a URL of my book that I'm going to sign in 1 hour or something like that during lunchtime. So if you're interested by Vertx, come at the Red Hat booth, you will get the book. If you're interested by Openshift, here are the different URL here. Thank you for attending, and if you have any question, but before that, I forgot one thing. It's time to give you the code. So let's take this, commit. My commit message are as good as my variable name. And here it is. I go to here. And if you go here, there it is. You already have the code that we just developed. You can run it. You have all the commands. Everything is there. Thank you. We have time for a few questions, I believe. Where have we time for questions? I think we have, yeah? Yeah. Okay, so do we have any questions? Yes, over there. So I repeat the question for the recording. How do we test it? That's a very, very good question, because testing asynchrony is hard. Fortunately, we have many solutions for you. The first one is something called Vertx unit that lets you write asynchronous tests, and failing the test or succeeded the test when the assertion run inside callbacks. Second way is to use something called awaitility, which is a library which will let you wait until a callback has been called. So if you prefer doing it synchronously, like you do today, use awaitility. It's a pretty cool library. If you are JUnit 5 users, then we have a library, we have an extension for JUnit 5 that lets you write asynchronous test too. One thing that is important, this is a library. Vertx is a library, it's not a container. So inside your unit test, the first thing you will do is Vertx equals new Vertx, deploy my vertical. You don't need to start it. Your test can start your application. It's just a library. So it's much simpler than anything. You don't need Arquillian or those things to test a Vertx application. You can start the application from your unit test. And it's fast. It's really very, very fast. Okay? Do we have another question? Yes, over there. Can we use Vertx and Spring Boot together? Yes, for the same reason. It's a library. So you just add Vertx, the Vertx core dependency to your POM file or Gradle file. You just do Vertx equals new Vertx, or Vertx.Vertx to instantiate a new Vertx object, and you're done. You can even use injections to inject this Vertx object inside all your beans. You can use with Spring Boot, you can also use that with Java EE, you can use that with any Java applications. It doesn't need to be a pure Vertx application. You can mix Vertx with almost anything. So then you instantiate Vertx, you have access to the event bus, you have access to the whole ecosystem. Because Vertx, here we have seen maybe 1%. We just scratch the surface. Vertx ecosystem is big. We support, well, we have an event bus, we support AMQP, we support different messaging like Kafka, we have integration with Camel, we have integration with set of database, Mongo, Redis, we have seen Redis, JDBC. We also have a fully reactive client for Postgre, which give very, very great performance. If you are looking for performances and you are using Postgre, look at it. It makes it first at to all benchmarks. And actually, we are not running the benchmark. So it's not biased. They are running the benchmark for us. And they scored us as in the top 10. And I think we are in the top 3 in terms of Java technology. So yeah, use it with everything. And you can use any part of the ecosystem with everything, because it's just a library. Yes? Sorry? Yeah. So how does it manage the event loops and the thread? So basically, an event loop can be summarized in a 3-line code. I have a queue of events, and I have my thread. My thread is looping and getting this event. Look at the interested handlers, so the methods that I have developed, and call it. And the next event, and so on. So you can say, yeah, but you are calling only one thing at a time. Yes, but because all my handlers are very fast and non-blocking, this is a golden rule, never block the event loop, then it will process all your message very, very fast. And then the next question is, yeah, but I have blocking code. And it's not an issue, because Vertx is also able to handle blocking code. We have constructs for this. We have something called worker vertical. We also have something called execute blocking, which will offload this task to a thread pool. It's not because it's another thread pool that this single thread approach is broken, in the sense that even if you use a worker's vertical, it's going to be always accessed by the same thread, so you don't need synchronize, you don't need volatile. Anyway, who can understand volatile? So, yeah, it's very, very nasty. So, in Vertx, you can, if you are in the event loop, never block it. If you have to block it because blocking code exists and there is nothing we can do, we provide constructs for this. So, execute blocking or worker vertical. Yeah, last question?
Just a quick question.
So what's the difference between Vertx and Akka HTTP? So let's divide it into, and what's the difference between Vertx and Akka? Both are about reactive, but they are using different philosophy and different primitive. Akka is about actors and distributed actors. So when two actors are interacting, it's using messages that can go across the networks and do persistence and stuff like that, and durability and so on. It's great. It's actually, I love some of the features. I would love to have some of the features from Akka inside Vertx. We are implementing them right now. But you need to embrace fully the actor model to use that. In Vertx, we give you much more freedom. What I didn't say about Vertx is that, well, I've used Java. But you can use Kotlin, Groovy, Ruby, JavaScript, Scala. I'm forgetting some. Go on the web page, all the languages are listed. And when I say you can use that, it's not using the interop level. We are really generating the Vertx API for all those languages using the idioms from the language. So it's provided a very natural experience. And actually the Kotlin has not been made or not been started by us. It has been started by the people from JetBrains. The Scala one has been started by someone that is a Scala expert and want to use Vertx with Apache Spark. And the Apache Spark API seems to be in Scala. I believe they also have Java, but it seems to be better. So he implemented like that. So you can use any of the ecosystems with all this language. So that gives you a lot of freedom. How about Akka HTTP? Vertx uses Netty, and it's pretty fast. It's what put very us at the top of any benchmark you will run. That's the main difference. And then something I didn't say is that the verticals can be also distributed like you will do in Akka using a distributed event bus. So a few differences is that our event bus is not durable, it's not reliable, and we design it like this on purpose for performance reason. So, and if you need durability, persistence, and so on, we provide client for Kafka, client for MQ, so, or RabbitMQ, so use the one you prefer, the one that you are actually using probably right now. So you can almost develop the same type of topologies, but with a lot more freedom in Vertx. Vertx is really a library. Akka is already a toolkit with a lot of things. And we don't bring Scala by default, so we are much lighter. Yeah, when I say Fadjar, who is doing Fadjar here? Nobody is doing Fadjars? What are you doing as a packaging model? You're zipping? Oh, yeah, you do Fadjars? Yeah, what's the size of your Fadjar? 100 megabytes? 100 megabytes? Yeah, okay, let's, give me a sec, let's have a look. Okay, open target. Okay, so that's the Fadjar we built. 7.8 megabytes. And it has Vertx, Kubernetes service discovery, the circuit breaker, and everything we use, the Redis client and so on. 7.8 megabytes. So don't call it a Fadjar, call it a low Fadjar. I think, where is my timing? Are we done? Oh, I have still have some time. Yeah, over there. How many verticals can you have? There is no limits. There is no limits. Inside your JVM, it's going to be your memory limits. But because verticals can interact in a distributed way, as soon as you have money to buy new EC2 instances, there is no limits. Because they can, the event bus in which verticals can interact can be distributed. So you can have them in different EC2 instances or in the cloud or and so on. On my machine, I think I hit the limits around 1,000, something like that. That being said, each one is going to be executed by a single event loop, but you don't have an infinite number of event loops because our event loops are assigned to a CPU cores, and I only have 4 cores on this machine, so I can have only 8 event loops. Why there is a factor 2 here, it's very complicated, I won't discuss on this. So 8 event loops means that only 8 verticals will actually have their own event loops. So if you are seeking for performances, don't exceed this number. If you are just want to compose and modularize your code as you want, then you don't care. Yep. So I mentioned the blocking the event loop, and I said never block the event loop. So when do we need to block the, well, when do we have blocking code? We have something called databases, Oracle, Postgre, MySQL. And because of JDBC, we have no choice. JDBC is a blocking protocol by definition, by specification. So there is nothing we can do. As soon as you use JDBC, you will need to offload some part of the work to some other thread to avoid blocking the event loop. There is a couple of other very interesting things, like logging. If your logging is writing to your file system, like log4j, SLF4j, or whatever, this is also blocking, but because accessing your file system is blocking. In Vertx, we provide a completely asynchronous file system support, but your logging library is not going to use that. So you need to be aware of these kind of things. Almost every network call or I/O call that is not managed using NIO is going to be blocking too. That's why we also provide NIO, lots of NIO clients. Web clients, we use that, IMQP and so on and so on. So you don't have to care. We do the gymnastic of the threads and of the NIO stuff for you. We are done. Thank you very much. And if you are interested, I will sign my book at 12, so noon, at the Red Hat booth. Thank you.